Welcome to Sairam Triple YouTube channel. Let us discuss Model 3 sequence network of a power system elements. We have positive sequence, negative sequence and zero sequence components. So already we discussed positive sequence, negative and zero sequence components. So in the positive sequence only generator is present, and then negative sequence component eliminating generator, we need to connect only impedance value, and zero sequence component we need to design based on the transformer. So sequence impedances: positive sequence impedance, negative sequence impedance, and then zero sequence impedance in the network. So synchronous generator, they mentioned generator because power system include generation side, right? So that's why they mentioned synchronous generator. See, this one is a synchronous generator, and there is a circuit diagram of synchronous generator with a stator impedance values, and then each impedances produce induced EMF of E1, EB1, EC2. So this is a equivalent circuit diagram of synchronous generator. See, this one is another one example with eliminating this one generator symbol. This one is a negative sequence component, right? So because we eliminated. Next we have a zero sequence component, so just we added a neutral over here, so it's a zero sequence component, right? So just one example. So with impedance, without impedance, right? So as you can see the diagram over here, this one is without impedance. So sequence impedance network, a three-phase transformer. This is a transformer impedance diagram, right? So this one is the secondary side and this one is primary side, right? So as you can see, zero sequence impedance will be equal to positive and negative sequence impedance. There is a path zero sequence current will be identified. If there is no path for zero sequence current, the following general observation can be made for the zero sequence current, right? So neutral point of a star connected winding is not grounded, then there is no paths of zero. See, just an example, like if it is neutral point is not there, if it is a neutral point is there, and with impedance, without impedance, it is considered, right? If it is depends upon star or delta also, right? So this one is a general circuit configuration of transformer. So this is the impedance zero sequence, right? So this part, and these are the diagram for configuration winding connection zero sequence network. So this one is star delta transformer, and this one is a star, and then this one is delta connection of zero sequence. This one is star to star, and then this one is star to star or zero sequence components. Next there is a star to star grounded. See here, star to star grounded, and this one is zero sequence components, right? This one is delta connection, right? Just you remember these diagrams, and then you can make design of this power system components, and then you can solve more number of problems. So similarly for this one also, delta to star and then star to star, similarity will be there. Just to go through that similarity, and then just to understand the concept. So sequence impedance network transmission lines. This is transmission lines, same as a transformer, right? So this one is a transmission lines of this one is positive, this one is negative, this one is zero sequence. So construction of sequence network of a power system. For this we need to solve some problems, because they'll give a problem like this. Okay, they'll give problem like this. We have to solve based on the like single line diagram, right? So this is the data they have given. So first we have to write, we have to draw positive sequence. This is a positive sequence while drawing while converting impedance into this diagram. So we get this one, and next we have a negative sequence component eliminating generator, and next we have a zero sequence like this, and some other diagram we will solve later.